Here's a more interesting, challenging problem. How about the integral from 4 to infinity 3 plus sine x squared over x dx? How could you approach that? All we want to know is whether this integral converges or diverges. We're not feeling obligated to find an exact answer, but an estimate might not be a bad idea. So what can you do with that? P-test, p equals 1, but then this numerator is complicated, right? So what can we do? So we have a complicated numerator. We can't use a p-test immediately. Well, what do we know about what's going on? What can we say about sine x squared? Well, sine of anything is what? Between -1 and 1? So what about 3 plus sine x? So we could add 3 to each of those. And then what? Well, let's go with this side. So that's true, right? So the integral from 4 to infinity of 3 plus 1 over x dx has to be bigger than the integral of sine x, 3 plus sine x squared over x. Does that help us? Well, what about this integral? We could move that out, so we could say 3 plus 1 integral 4 to infinity. It's just a coincidence we got 4's here. Don't worry about that. What is this integral? There you can do a p-test with p equals 1. So horizontal p-test, p equals 1, so the integral, what, diverges? Okay, so our original integral is less than or equal to an integral that's infinity. So what does that tell us about our original integral? Nothing. Could still be infinity, just slightly smaller infinity, like 90% of that infinity. So we get no conclusion. Well, what else can we do? Well, we just said our original integral is less than a divergent integral, which doesn't help us. Can we go with the other branch over here and say that -1 plus 3 equals 2? I think that's not controversial. So we can say our original integral, 3 plus sine x squared over x, how does that compare to just making the numerator 2 here? We know that this value is always bigger than or equal to 2. And so this integral is always bigger than that one. What we're doing here, we put an upper bound. Let's think which one was an upper bound, which one was a lower bound. This one was an upper bound, so we'll do that in blue. So that was 4 over x. And that didn't really help because the area under that was still infinite. But now we're doing something like that. And this would actually touch. I'm just being a little sloppy drawing it. This one's 2 over x. And what can we decide about that? This integral diverges to infinity. Again, p-test with p equals 1. So if this side is infinity and this side is at least as big as that, we can say our original integral also diverges. So was this a limit comparison test or a direct comparison test? This was a direct comparison because we knew directly this thing was always bigger than that thing. So a direct comparison test. But it took us a little while to, we had to try something, see if it works, see if it didn't work, try something else. That's life sometimes, right? Okay.